So this first page was the important. Really, this is the most important stuff because these are the types of questions they're going to ask you. They're going to ask you about speed, they're going to ask you about velocity, they're going to ask you about acceleration, position, when a particle's at rest, when it changes direction, when is velocity increasing, when is speed increasing, when is speed decreasing, all that stuff. This is exactly the questions they're going to ask you. And then as well, they're going to ask you, when does an object move left, when does an object move right, when is it stopped? So this is our reference sheet. You're going to be using this quite a bit. And when we take the test after break, after Thanksgiving break, I encourage you to have a lot of this stuff on your card because so you don't have to memorize it, because that's the stuff that, you know, there's going to be questions like this definitely it's very popular, position, velocity, and acceleration on tests. Okay? All right, so we stopped on number 5. So number 5 was the last one we did. Using the graph, we had to tell when speed is decreasing. Okay? That was the last one that we did. So now number 6. Number 6. Okay, so we get a graph again. Different graph, but a graph. A particle moves along the x-axis so that its velocity goes from 0 to 18. So time goes from 0 to 18. Is given by v of t, whose graph is shown in the figure below. The inflection points of the graph are marked with green circles. There's circles on yours, but they're not green. So we have to find all intervals when speed of the particle is increasing. So when is speed increasing? That's the first thing. When is speed increasing?
When acceleration and velocity have the same sign.
Mm-hmm. When acceleration and velocity have the same exact sign. Speeding up, slowing down. Acceleration, so speeding up and slowing down. Here and here, when velocity and acceleration are both positive or both negative. Okay, so when they have the same sign. Okay, so let's write that down. Let's see. When velocity is positive and acceleration is also positive. Or vice versa. Either of those will make speed increasing. So we got to look at the graph. Okay, we got to look at the graph to determine where that's happening. Okay, so what is the graph of? What is the graph showing us? Velocity and time, right? Velocity. In other words, it's the first derivative graph. It's the first derivative graph because velocity is the first derivative of position. Okay, that's the first thing. So we're looking at the velocity graph. So let's start with this guy. Let's start with velocity positive. On the graph, where is velocity going to be positive? Where do I look? Above the x-axis. Good. Above the x-axis. So everything above the x-axis is going to be where velocity is positive. The opposite is when velocity is negative. So when is velocity going to be negative? Below the x-axis. Good. Okay, got that? So now we know where velocity is positive, and I know where velocity is negative. Okay? Acceleration. How do I tell on the graph when acceleration is positive or acceleration is negative? We're going to look at slopes, right? We're going to look at slopes. So when the slope is positive, acceleration is positive. What does that mean in the graph? When its slope is positive? going uphill. It's going up, right? So from 0 to about 4, we're increasing. 0 to 4. I'm increasing. I'm going uphill. So that means acceleration is positive. And then from 4 to 9, decreasing. Okay. And then from 9 to 12, acceleration is positive again. And then at the end, acceleration is negative because it's decreasing. Okay, so now we know everything. So now when are velocity and acceleration going to both be positive? When are velocity and acceleration both positive? In other words, greater than sign and yellow. I need a greater than sign and I need yellow. So 1 to 4, yeah, that works. Yeah, sorry. Yeah, I was looking at the wrong spot. 1 to 4, yellow, greater than. So let's write that down. Let's write this down. Speed is increasing. Increasing from 1 to 4. Okay, good. 1 to 4, good. I have yellow and greater than. Where else?
9 to 12.
Yep, yellow and greater than. 9 to 12, good. Anywhere else? 17 to 18. That's going to be for the other one. Yeah, it's going to be, yeah. So these two are just when both are positive, right? So I think we're good for both positive. How about both negative? 17 to 18, right? 17 to 18 would be the only spot because we're looking for pink and we're looking for less than. So 17 to 18 would also be on here, yeah, for the opposite reasons. Because, how did we know those areas? Because velocity and acceleration have the same sign. Okay, that's how we know both of those, or those three are correct. Okay. All right. All right, let's look at the next one. Let's look at the next graph. There's 2 more graphs, and then there's a practice problem, and then we're done. Okay, so here we go. Number 7. Particle moves along the x-axis from 0 to 18 when time is 0 to 18. Okay, that part is the same. Is given by x of t. The graph is shown below. The inflection points are marked with circles. Find all intervals of time when particle has a negative acceleration. So negative acceleration just means a of t is negative. That's all that means. Acceleration is negative. So I got to tell when acceleration is negative by looking at the graph. Okay, so what do I know about the graph? What's the graph showing me, in other words?
Position and time.
Position and time, right? Not velocity and time anymore. It's not like the last two. The last two were velocity and time, first derivative. Now we got the original. This is the original guy. This is the original graph. We have to find acceleration. So what's the relationship between position and acceleration? Second derivative, right? So what we're going to have to do is find second derivative of this guy. How do you find, what do you look for when you're looking for second derivative on a graph? Two things. Not slopes, that's first derivative. First derivative is slopes. What's the second derivative?
The concavity.
Concavity. Concave up, concave down, right? Concave up, holding water. Concave down, spilling water. Okay? So let's label this graph. So we're looking for concavity. So concave up, let's see. Concave up, concave down. So I'm going to color code this just like I did the last ones. Okay, so blue will be concave up. Orange will be concave down. Okay, so this guy here, how does it, let me see. So how does it start? So let's start from the very beginning, from 0. Is this concave up, holding water, or spilling water? It's holding water, right? It's holding water because it's got this little dip here. When does it change to concave down? Not 7, before 7. No.
You said before.
So what are the circles? What are the circles again?
The inflection point.
So what are inflection points? What's the definition of an inflection point?
When the signs change. Or no?
Yes, but what are the, that's how to find it. What is an inflection point? I'm asking, what is an inflection point? Not how to find inflection. I know how to do that. I can just look at the circles. What is an inflection point? The answer is I'm not going to tell you because you know. Anything you know, I shouldn't have to tell you. What is an inflection point? Those of you looking at your notes, I appreciate you guys. There you go. An inflection point is a change in concavity. That's why all of these guys were inflection points. It changes from one to the other.
So that means 5 is when it changes.
So they're actually giving us part of the answer. They're helping us with the changes, right? The changes are here, here, the circles. Those are all the changes. Means I'm going to change from concave up to concave down. So what did we say was happening from the start? Concave up or concave down? Concave up, right? The first circle means we're going to change. I'm not going to be concave up anymore. I'm going to be concave down. So let me change the color. Change it again. Change it again. One more time. Okay. So it helps us. We don't have to decide where it changes concavity because they tell us. That's what inflection points do. Inflection points tell you on the original. We didn't use inflection points. We didn't necessarily use those on number 6 and number 5 because we didn't care about second derivatives. We had the first derivative already. But now we do care about second derivatives. So that's where concavity will help. Okay? So negative means concave down, right? This is when so we're just looking for the yellow, or sorry, the orange now. All we're looking at is the orange. So we say negative a of t, or acceleration, from 5 to 7, or 9 to 11. Because, oh, I should put because that's where the second derivative, that's where acceleration is negative. So all depends on which graph they're giving you. If they, let's say this is a new problem. Let's say it wasn't this guy. Let's say it was v of t, and they wanted you to do the same thing. Let's say this was v of t, and they wanted you to do the same thing. How would we find concave up and concave down?
Isn't it the same way? Or no?
No. We just did it on number 6. We just did it on number 6. How can I tell where acceleration is positive and acceleration is negative?
Across the x-axis?
No, you're close. That's where velocity is going to be positive and negative. What about acceleration? There you go, increasing, decreasing. Okay? So if you're looking for the first derivative, increasing, decreasing. If you're looking for the second derivative, concavity. If you're looking at what you need to look at, like if they asked me questions about position, I would just use the y values. Okay?
So if it was just asking for
If they were asking you if x of t is positive or negative, I would just look at the y values.
okay.
Yeah.
So then since this was first derivative or second derivative, first derivative, we gotta do that, and then for the second, you have to
Yeah, increasing, decreasing, right? Or slopes, positive or negative. And then what I had to do on this one was concave up, concavity. Depends where you start. So if you start at the top and you need to find acceleration, that's concavity. If you start at the top and you need to find velocity, that's slopes. If you start at velocity and need to find velocity, that's everything moves down. It shifts. It's like a sliding picture. It's a sliding scale, which that's what makes it difficult. So y values, slopes, concavity. So it's kind of a sliding scale. What I mean by sliding scale, this guy slides up and down. This guy will slide up and down. So you just got to kind of organize it where you want. Sometimes x of t will be the y values. Sometimes v of t will be the y values. And then everything shifts down one. You know what I mean? Okay, so it's knowing what they've given you. How do you know which one? Well, what do they give you? Let's start with that. What do they give you? And then once you know what they give you, then you can kind of sort them out. Okay? All right, let's look at number 8. Try number 8. I want you guys to try it. Try number 8 on your own. So what do they, we'll start with that. What do they give you? What's the given information? Position versus time, right? So that means position is the y values. V of t is the slopes. A of t will be concavity, just like the last one. Whereas in number 6, it was a sliding scale. It was a x of t, we didn't even have, v of t, a of t, right? So this guy was y values, and this guy was slopes. Okay? So it's a sliding scale. Okay? That's the difference. Just depends on what's given. What is given, that's when you start. Okay? Okay, so find the intervals when the particle is moving to the right. Moving to the right. What does that mean, moving to the right?
Velocity changes signs.
Velocity changes signs to
Positive.
positive, yeah. When velocity changes to positive, good. Velocity changes signs to make it positive. Okay. So according to my sliding scale, v of t is going to be the slopes, increasing, decreasing. So the first thing I'm going to do is where is it increasing, where is it decreasing? So I'm going to say increasing will be yellow. Decreasing will be same color I used earlier, that pink color. We don't have to worry about concavity on this one. So the question said, when is it moving to the right? And we said that means yellow, right? That's yellow. So we're just going to look for the yellow. So the yellow goes from, so we say particle moves to the right from 0 to 4 or 7 to 10. Okay, because why? Velocity is positive. Or you can say the derivative, you can say, so there's two ways to say this. You can say velocity is positive, you can do that. Or you can say x prime of t is positive, because it's the same thing. It's the same thing. They have, remember, velocity's got lots of names. Position has two names, x of t or s of t, it depends on what they give you. Velocity has x prime of t, s prime of t, or v of t, and then acceleration has all types of names. So any of those names are okay. This one we're just looking for, we know the particle or the object is moving to the right when velocity is positive. They've given us the position graph, so according to our sliding scale, position is the y values, v of t, velocity is the slopes, a of t is concavity. Okay? Now, if they asked us the same question, but let's say the same thing I asked you earlier, what if this was v of t? Then we would look like that. Okay? V of t would become the y values. A of t would become the slopes. Okay?
So in that case, we would just looking for the y value rather than.
Well, yeah, we would use the y value. Exactly. It's just that sliding scale. That's the hardest part about it. That's the hardest part about that is that sliding scale. Well, I always start with whatever they give you, that's the y values. So if they give you x of t, y values. If they give you v of t, that's the y values. If they give you a of t, that's the y values. And then go from there. We won't, like I said, don't worry about going up. Just got to worry about going down. Okay? It's going down scale. Okay? All right, one more practice problem, and then we'll be done for today. Okay? So this is a multi-parter. This was a a free response question that I used to give on tests. So I stopped giving it after a while, and I just put it on the notes because it's just a test type question. Okay, for this. Okay. To save his son, Luke Skywalker, from certain death, Darth Vader picks up the Emperor and throws him off a ledge on the Death Star. As he falls, the Emperor's position, S, should be S, or not, is given by the function s of t. So now they're calling position s of t. Where s is measured in feet, t is measured in seconds. Okay? So sliding scale. Let's change this to S. Y values. So if I want to know anything about position, I plug it into there. If I want to know anything about velocity, I got to find the first derivative. If I want to know anything about acceleration, I want to know the second derivative. Okay? Okay, so first question. What is the emperor's displacement from 1 second to 2 seconds? We haven't seen that word. It's in the first page, we just haven't seen any questions with it. What was displacement? What is displacement? Say it again. How far from where you started? Okay. So if I start here, like I said, if I start here and I take 1, 2 steps, I'm 2 spaces away from where I started, right? But if I go 1, 2, and then I go back 1, I've taken 3 total steps. That's distance, that's total distance. But displacement's only 1. Okay, so that's the difference, okay? So we have to figure out where was he at 1 second, where was he at 2 seconds, and then subtract. Position at time 1, position at time 2. So how are we going to do this? Plug in the numbers, see where he's at. Yeah, see where he's at 1 and then 2. Okay, so S of 1 and S of 2. Negative 16 st squared, so 1 squared, plus 16 times 1 plus 320. So that's negative 16 plus 320, which is just 320. That's where he was at time 1. Time 2, negative 16 times 2 squared, 16 times 2 plus 320. So 2 squared is 4 times negative 16 is negative 64. 16 times 2 is 32 plus 320. So negative 64 plus 32 plus 320, 288. So I didn't label these, but you should because they've told us what is 320 and what are 288. What is going to be the measurement, or what is going to be the units? Which is what measurement? Feet. Good. Feet. So how far is he from where he started? So where did he start, at 1 or 2? 1, right? He started at 1, ended at 2. So we're going to subtract 288 minus 320. Not the other way around. Okay, so you get negative 32 feet. What does the negative represent? Falling, yeah, he's falling, yeah. 1 second, he's here. Another second later, he's 32 feet below where he went. So that's negative means just direction. Which direction is he going? Okay. Here's the question now. When will the emperor hit the ground? So actually this question is not a calculus question because actually the first 2 aren't calculus questions because you don't have to find derivatives or anything. How do we know when the emperor is going to hit the ground? How can we figure that out? So in your mind, come up with a visual of what's going on. Okay, the visual is Darth Vader picks up the Emperor and throws him off a ledge. Okay, so picture that in your head. Now let's draw that on a graph. The x is time. This is position. Where would the emperor start? Roughly. High, yeah, on the top of the graph, right? Because at time 0, it's actually 320. It's actually 320 because if I plug in 0, 0, it'd be 320. So the emperor is 320 feet high. Right, this is feet. Okay. At time 1, he's 320. Wait. Okay, so at time 1, he hasn't gone anywhere. Okay. At time 2, he's at 288, right? So 288, let's just say right there. Right? Eventually, he's going to hit the ground. Right? The ground is 0 feet, right? So what the question is asking you is, what will the time be here? What will the time be here? That's what the question is asking you. So how do we do that? Say what equal to negative 32?
The SFC.
So when I hit the ground, how many feet am I from the ground? 0. So you're not going to set it into negative 32 because that would be underground. 0, yeah. 0, there you go. So negative 16t squared plus 16t plus 320 equals, when does that equal 0? 0 means hit the ground. Well, this is a quadratic. So GCF, you can divide them all by negative 16. Uh, 20. So we're looking for the two numbers that multiply to be negative 20 and add to be negative 1. Negative 5, positive 4. Negative 5, positive 4. What's t going to equal? 5 and negative 4, yeah. 5 and negative 4. So when is he going to hit the ground?
5.
Time is 5. After 5 seconds, right? 5 seconds. Not negative 4 because we can't go back in time. So emperor will hit the ground at 5 seconds. Emperor will hit the ground at 5 seconds. So they haven't asked us anything about velocity or acceleration. So we haven't had to find derivatives yet. We will, but not yet. We haven't had to do that yet. Okay? All right. Letter C. What is the emperor's velocity at impact? Well, when does impact happen?
5 seconds.
At 5 seconds, right? So t equals 5. So how do we figure out what his velocity was? take the derivative, right? Take the derivative, good. So let's start with that. The derivative is velocity, so it would be negative 32t plus 16. Good. And then what do we do? Plug in 5, yep. Plug in 5. Negative 32 times 5 plus 16. So negative 32 times 5 is negative 160. Plus 16 is negative 144. Two questions I have. First question, what are the units? What are the units going to be? So velocity, so what is velocity? Is velocity a distance? Is it a rate? What is velocity? It's a rate, right? A rate is a distance over time, okay? So how are we measuring the distance? In feet, right? So it's going to be feet. How are we measuring time? Seconds. Yep. The way I think of it is in your car, right? In your car, it's not velocity. Well, it's speed, right? Speed and velocity are very similar. It's miles per hour, right? It's not miles, right? When it says 35, it's not 35 miles, it's 35 miles per hour. So that's a rate.
So velocity is just,
So velocity would be negative 144 feet per second.
so if like S was like yards and T was like hours, then it would be yards over hours.
There you go, yeah. Yep, it's whatever they give you. Okay, so my next question, that was the first question. My next question is, it's negative. When I go in my car, it doesn't say negative any miles. What's the significance of negative?
Negative could be for velocity, but not for speed.
Because, you're right, absolutely, you can have negative velocity, because what does that signify?
It's displacement, not the distance.
No, what does the negative signify? What does the negative signify? It's falling down, right? Falling down. He's coming down. His position is going negative, right? His position, because this is position over time. It's really position over time, right? That's what velocity is. Change in position over time. And he's falling straight down. So that's why it's negative. That's what it signifies, falling down. Right? Your car doesn't do that. Your car, even if you change direction, it's always going to be positive because it's speed. It's speed and not velocity. Okay?
So it's decreasing at that rate too?
That's what it means. He's losing position over time. Losing position over time. Position is going down. That's what it signifies. Seconds isn't negative. It's the feet that are negative. Okay? All right, so last two. Last two questions, I think. Yes, last two. What is the emperor's speed at impact? It's just going to be positive 144. Because isn't velocity, speed, equal to the absolute value of velocity? Right? So speed equals negative 144 absolute value. 144. What's the units for speed? Feet per second. So everything's the same, just positive. Okay. Last question. Find the emperor's acceleration as a function of time. Okay, so what does that mean as a function of time? That means just give me, what that means is give me the equation. Give me the function. Give me the equation. Don't plug in any numbers. Just give me acceleration. That's what that means. You don't need to plug in any numbers. Just give me the function if I needed to use it. Okay? So it would be the second derivative, right? So what is the second derivative going to be? Minus 32. Minus 32. Okay, so there's no variable there, right? So what does that mean? If there's no variable, what does it mean?
Time is just zero.
Not time. If something doesn't have a variable, instead of, like for example, instead of 2x, I just say 2. No. Like for 2x means I can, what does it mean when there's a variable?
Multiply.
And what does vary mean? When I say variable, what does that mean? It changes, right? It changes, right? It can change. Variable means it can change. No variable means what? It's a constant. It doesn't change. Why is that? That's the gravity. That's the gravity. Gravity doesn't change. When you're falling, gravity doesn't change. Okay? It's not like he fell really slow and then sped up, right? That's not what gravity does. If you fall, you're going to fall. You're not going to change accelerations. Okay? So acceleration. So acceleration is, so when you're doing acceleration, let me give you that since we haven't done that. It's distance, because it's a rate of a rate. It's a rate of a rate. So it's distance over time, but squared. Time is squared. That's the difference, because it's a rate of a rate. It is a rate, but it's of a rate. Regular rates are just rates of position. This is a rate of a rate, so that's why it's squared at the bottom. So the distance is feet, and then seconds squared. So if they ask you to do units for acceleration, it's always distance over time squared. Distance over time squared. Velocity is just distance over time. I'll write that down. Same with speed. Velocity is distance over time. Miles per hour, feet per second, that kind of thing. Same thing with speed. Speed is distance over time. And then position doesn't have any time. It's just distance. Position is just distance. Okay. And that's it.